Hi everyone, my name is Juan Carlos, and today we're going to work with tutorial number 6 of Patran called Frame Surface Model Analysis. And well, the workshop objectives are to create a finite element model, uh, dead loads, operating loads, and gravity loads, constraint nodes. For a intermediately difficult frame system using MCS pattern. Okay, now, well, let's start. First, we need to open the file. It's already open. Um, then we need to go to create, group create, and we create a new group. We will call it FEM surfaces. We need to check that this box is checked and apply and cancel. Okay. Once we finish this, we need to go to meshing. We're already in meshing. Or element, depends um your program. And I think 2015 you don't have meshing, it's element. So we go to meshing. We go to create for action, object, mesh, and type surface. Okay, now we have this 3 over here. We need to change the measure from iso mesh to paver. Okay, once we did this, we need to select all the surfaces. Okay, and we have a automatic calculation of 1.6. We will change it. The practice says that we need to change it to 1, but since we are working with the student edition, that will generate some problems, and so we'll be working with a value of 2.0. Okay, now let's apply. Okay, now it's meshing. Perfect. Now, well, we can see we have our mesh, and now we need to get the equivalence nodes. For that, we go to action equivalence, all tolerance cube. We keep this with a value of 0.005 and just apply. Okay. Now we need to show the element free edges. For that, we go to verify element boundaries, and we keep it in free edges and apply. Okay. Now we need to change the verify element. We need to check we need to verify the elements. So we go to quad and test aspect, and we need to get the a aspect ratio of 5, and I think that's it, and apply. Okay, there. Okay, now looks good. Yeah, it looks good to me. Now let's go to, okay, we need to, well, the next step is to go to group. We're going to post, select all surfaces, apply and cancel. Okay, now we need to create a dead load. For that, we first need to get our surface shade, a smooth shaded view. Now we're going to create the loads. Go to loads, PCS, to create force. We need to change this to force, nodal, and we're gonna call it dead load. Input data 0 minus 150 and 0. Okay. Now I'm going to select the application area, and we will use this point over here. Okay. And this point, I'm sorry, over here. 0.60 and 0.3. Yeah. We add it, and okay. Now we apply the forces, and we can see that we have our force vector here and here. Now we are going to generate 2 more forces. We stay in the same window. We don't change anything. We need to change just the name. We'll call it dead load 2. The input data 0 and okay, 0 minus 960, 0, and I think that's it. Okay, select application region, and we select the points over here. This point, 0.80 and 0.37. Yes, okay. Add and okay, and apply. And we have our new forces. Okay, now we need to create a operating engine static load. For that, we stay in the same window. We just change the name to static load. Static load. Okay. Go to input data minus 100, and I think it's XY, it's Y, and minus 100. Okay, looks good. Okay, now we need to select the application area. Okay, and we will pick the same points that we select. 0.37 and 0.80. We add it and okay. Okay, let's change the view, fit view, and the ISO. Okay. I don't know why. Oh, we need to apply the forces. Apply. There. Okay. And although the forces directions may appear vertical, they are in fact off angled. So we can see it in this view. No, it's this one. They have like a little angle here. So that's what we were looking. Now we need to create a gravity load. Now we will change this to inertia load and the type to element uniform. Yes, we set the name of gravity, and select the input data. It will be 0 minus 386.4 and 0. 386.4, 0. Okay. Now we select the application region. There's no application region, I'm sorry. Because it's a gravity force. So, well, that's it, apply. And we can see the new force over here, the purple one. Now we need to create a constraint for the frame support. We go to displacement, nodal, we'll call it fixed space. The input data will be 0, 0, 0. Okay. And we need to select the application region. The application region will be 4 points. The point over here is 0.90. The point over here, 0.1. Point over here, 0.52. Oh, damn. And the point over here, 0.98. 52, 1, 90, and 98. Okay, now add and okay. And apply. Okay, we can see we have new colors in our geometry, in our surface. This 4. Okay. Now we need to create a constraint for the frame support. And first we need to go to load PCS. I like this view, we're gonna keep it. Then we go to I'm sorry. We go to home, to display, to load BCS, and here we need to uncheck this one here. Just keep the one in the middle, the vectors. And what else? and we apply. I think that's it. We apply there and cancel. That's it. Now we need to define our material. So we go to properties, isotropic, because we'll be working with a isotropic material. We go to the material name. It's aluminium. Aluminium. Okay. Now we go to input properties, and we introduce the value of elastic modulus of 10 Poisson ratio 0.3, and the density 0.61. Okay, and now, okay, we apply the material. Okay, it's done. Now we need to define the properties for the frame structure. We go to properties. We are in properties. Just change this to I'm sorry. What? Create. Okay, something's there. Okay. Okay. Shell. We need to set a name. We're gonna call it all frame flange. Frame flange. Select the input properties. We select the material, the aluminium, and we set a value of thickness of 0.75. Okay, and well, I think that's it. The tutorial, the practice doesn't says you need to apply, but I think it's obvious that we need to apply. Okay, so we apply the, oh damn, no, sorry, I'm going to undo this because we didn't select the application area. We need to select this flange over here and the flange over here. To do it, we'll go to the front view and we will select this one, and oh no, we're missing a little part. First we need to go to preferences, to picking, and we pick the enclosed entire entity here. We need to change from this to this, and I think that's it. Now we select this part, shift this part. Okay, and we add it. I think we're good. I hope we're good. I really hope we're good. And now we apply. Okay, now we need to define the properties for the frame structure for this part. So we stay here. We just change the name to frame width. Change the input properties. Change the thickness to 0.5. The material stays the same, it's aluminum. Okay. And we need to select the application region. And we will select all this part in the middle between the two frames. What? I'm sorry. I don't know why it's not working. View, front view. Okay. What's wrong with this? What's happening? Okay, we also need to change this. We select this there. Okay. Important, very, very important. We need to go to preferences, to picking, and to change once again the entity picking cursor to select the web between the flanges. We add it and okay, and apply. Okay, perfect. Now we're going to check the loads. For that we go to it's not load PCS, I guess results. Let's go to results, action, no, PCS, modify. No, we're not in the correct